As we wrap up Unit 11, our final lesson is going to be on dividing integers. So we're going to talk first about dividing integers with the same sign. So the quotient of two integers with the same sign is positive. So that's going to be very similar to what we learned about multiplication of integers in the last lesson. We've got two examples here. A positive 8 divided by a positive 2, of course, is going to be a positive 4. And then a negative 8 divided by a negative 2, so we've got two negative numbers, both with the same sign, will also be a positive 4. When we have integers with different signs, the quotient of those two will be a negative. And we've got two similar examples. A positive 8 divided by a negative 2 is going to yield a negative 4, and a negative 8 divided by a positive 2 will be a negative 4. So once again, if they are different signs, you are going to end up with a negative quotient. So let's work through some examples here. First thing I notice here about number 1 is I've got two integers with the same sign, so I know my answer is going to be positive. It might be helpful for you to go through the problems first and to identify first just what the sign will be and then do the math. So I know that this one here will be positive. I have a positive and a negative, so if it weren't a 0, I know this one would be negative. I've got a negative and a positive, so that one will end up being a negative, and then a positive and a negative, so I know this one will be a negative as well. You might find that it's just kind of a helpful strategy, and now you can just focus on doing the math. So negative 48 divided by negative 6, I know it's going to be a positive because they both have the same sign, and I know this is going to be a positive 8. 0 divided by negative 6, like I said, if it weren't a 0, the quotient would be a negative. However, it is a 0, so there is a 0 in the problem, so it's just going to be 0. Negative 49 divided by 7 has one negative and a positive, so it's going to be a negative 7. And 14 divided by a negative 2, again, will be a negative because of the two different signs, and that will be a negative 7. As we go about evaluating expressions, we are simply going to take the information the problem tells us and plug in the value for x and plug in the value for y, or whatever the variable happens to be. So in this case, we've got x minus 8 divided by y squared. X will be equivalent to 4 and y will equal 2. So if I were to rewrite this problem using the information they gave us, I would have 4 minus 8 divided by y is 2, so 2 squared. So I'm going to solve my numerator, solve for my denominator, and then do the division. So a positive 4 minus 8 is going to give me a negative 4. Positive 2 squared is going to give me 4. My answer here will be a negative 1. So let's work through evaluating some expressions when a is negative 18 and b is negative 6. I've got two negatives here, and so in this case, I know I'm going to end up with a positive answer. Negative 18 divided by negative 6. I've got the two negatives, so I know my answer is going to be a positive 3. Here I've got negative 18 plus 6 divided by 3. So let's just work through the numerators first so we can get this down to two integers. Negative 18 plus 6 is going to be a negative 12. Now we can divide by 3, and I've got a negative integer and a positive, so I know my final result, my quotient, will be a negative 4. And b squared over a plus 4, so negative 6 squared over negative 18 plus 4. I'm going to end up with a positive 36 over 18. and then add 4. PEMDAS tells me that I need to do the division first. So 36 divided by a negative 18. I know this answer is going to, this quotient is going to yield a negative 2. Now I can add that 4, and I'm going to get positive 2 as a result. The final questions we are going to look at, of course, are application questions. So we're going to be talking about the tides. The morning high tide at a beach is 57 inches. 6 hours later, the afternoon low tide is 12 inches. So this is the information I want here. And then, of course, our question is, what is the mean hourly change in the height? So the mean would be the average. So we're going to be working with the average change in the height. So here's how we solve for that. So we're going to take the mean hourly change, that's what we're looking for, and we are going to find that by taking the final height, and we are going to subtract from that the initial height, which is your beginning height, and we are going to divide all of that by your elapsed time. So how much time passed in between the change of the final height to the initial height, or from the initial height to the final height. So in this case, we can go ahead and plug in our final height was 12 inches, our initial height was 57, and the elapsed time was 6 hours. Okay, so when you take 12 positives and subtract 57, you are definitely going to end up with something very negative. Negative 45. And divide that by 6. And you are going to end up with, I believe, that should be a negative 7.5. And inches. All right, and one very, very similar, just so we can practice filling in for the equation. The height of the tide at the Bay of Fundy in New Brunswick decreases, that's an important word there, decreases 36 feet in 6 hours. So we know that it is going to go down 36 feet in 6 hours. What is the mean hourly change of the height? So in this case, I don't have a final height and an initial height. I already have the result of this portion of my equation in that it tells me that the difference is 36 feet. So it's already given me the answer for the final height minus the initial height. So decreases, of course, means that it is going down, so we apply that negative sign. So we've got the negative 36 feet in 6 hours, 6 positive hours. What is the decrease, the average mean decrease? That is going to give us negative 6 feet per hour.